I really appreciate it. Thank you for reminding me. So this section is the there are two sections left in this chapter, section 20.4, 20.5, and then after this, that's it. I think we can also do 20.5 a little bit, and that's for chapter 20. We don't have to do any other section. And then we're going to go to chapter 27. Again, talk about the derivative of sine function, the derivative of cos function, the derivative of tangent function. That's why I did this chapter before I do the derivatives, you know. This is included on the test, not the ones of chapter 27, no. This test will include sections, 24.5, 24.6, 24. No, there is no 24.6. It's the only x-intercept from 24.6 and 24.7, 24.8. 3 sections in chapter 24 and about 5 sections in chapter 20. Okay, so we won't have any chapter 27 in this test. Chapter 27 will be test 4. In case you want, okay. I posted practice test. It's not gonna be the trig functions. Though chapter 20 might be a little bit hard because the formulas, maybe if you are learning this, it might be difficult. But actually, you should have done that before we come to calculus. That's what the idea is. So I think the practice test will give you a guideline on how the what I expect. You know what I mean? So it might not be as big as the practice test. The test might be shorter. It will be shorter. But for practice, I added more for your practice. Okay. All right, so let's there is a short section which is called half angle formula, but it probably is the most important, I think. Okay, so for half angle formula, remember what we had for the cosine of 2x. Cosine of 2x is what? Cosine of 2x is cos squared of x minus sine squared of x. This is the main source of half angle formula. This is from previous section, from 20.3, from section 20.3. So the idea is no, actually not this. Of course, this is not the one, but the other versions. These are split to 2, right? This relationship cos of 2x, what was the one? It is 2 cos squared of x minus 1. The other one was 1 cos of 2x equal to 1 minus 2 sine of squared of x. Isn't it? Remember, we had 3 versions of cos 2x. So this line will give me a relationship for the cos squared. What is cos squared? Let's solve for cos squared from here. 2 cos squared x, you can take the 1 to the left-hand side, 1 plus cos of 2x, and then divide by 2, cos squared of x equal to 1 plus cos of 2x divided by 2. This is the first half angle formula for the cosine squared. In here, I can solve for sine squared as much as I did for the cos squared. So all I got to do is take this to the left. 2 sine squared of x, and take this to the right, 1 minus cos 2x. So sine squared of x is 1 minus cos 2x over 2. This is another half angle formula, right? Okay, so I think this version is one way. Okay, cos of x then becomes plus or minus square root of 1 plus cos 2x over 2. And then he says sine of x then is plus or minus the square root of 1 minus cos 2x over 2. But I prefer those. The squares, see the relationship. The square on the x, the square function has x as an angle. The no square, which is a degree 1, the beauty or the interesting part of this is the squared is halved with the exponent. The exponent on here is halved here. That's why they call, maybe not, that's why they call the half angle formula. But maybe the angle is half of this one. So, they sometimes these half angle formulas are called reduction formulas that reduce the exponent. Okay. So please realize the setting, the writing. Realize the writing. So 1 minus cos 2x over 2 is sine when there is minus. When there is plus, it's cosine squared. And I'm comparing squared versus no squared. So as an example, can you give me an example? What is cos squared of 10x? First of all, it's squared. So the expanded version, which is 1 plus cos of, what do you do? Double or half the angle? Yes, 20x. Arthur, you're right. 1 plus cos of 20x over 2. They are the same. So what is so 1 minus sine, no, there is no 1 minus sine in the half angle formula. So 1 minus cos. Both of them are cos. Here, cos, here, cos. One is with minus, which is a sine squared. One is with the plus, which is a cos squared. So 1 minus cos of 4 theta over 2. What does that mean? Do you recognize it? Isn't it this? 1 minus cos of 2x over 2, where theta, in this 2x, x is 2 theta. So it is sine squared of 2 theta. Is that okay? Sometimes they might give you, what is 1 plus cos 2x? Imagine if there was 2 here, you would have said what? Cos squared of cos squared, yeah. Cos squared of, yes, yeah. the 2 multiplier, I will explain. You're right. So cos squared of x would have been, right? There was no 2. If there was 2, so therefore the 2 will come here. So 1 plus cos 2x is equal to 2 cos squared x. So please, everybody should participate. Like, you should think about it. Before we do examples from the book, I want to make clear what is cos squared of 6x. How could you change it into that expanded version of the half angle formula?
Would it be 1 plus cos 12x divided by 2?
Thank you. Excellent. That's right. That's very, very crucial. We need to understand. Sine squared of 20x is what? If it's sine squared, remember, on the left-hand side, I'm saying square. If there is no square, you should do a square root on the right-hand side, mind you. If there is no square, so, okay, sine of 6x, you should say 1 minus cos of 2x, no, 12x over 2, right? So anyway, in this case, because there is a square, sorry, 1 minus cos of 40. Thank you. Thank you, Sivan. 1 minus y minus because it's sine. It's plus only if it's cos. Okay? 1 minus cos. Both of them have cos. And double the angle, 40x over 2. Thank you. So now I'm not saying sine of 20x is 1 minus cos of 40x over 2. No. You got to have a square here. You got to relate all of them correctly. Okay? That's all what my students miss all the time. When I introduce a new formula, they partially pay attention to one piece, and then they end up making mistakes. So got to be completely matching before you replace. Now we are ready to do the examples from the book. Sometimes the book gives you with a square root, which is no big deal. If you want a square root formula, that's what it is. There's no square, and no square root on the right, square on the left. No square root on the right, square on the left. But if there is a square root, no square. Okay, let's do page 564 examples on section 20.4, page 564. So number 10. What is square root of 1 plus cosine 176 over 2 mean? No. So there is a square root, then the answer will be, you see the exponent here is half, so the answer will be with 1 degree and with 1 exponent. So it is it sine or cosine? What's indicated here?
Cosine
Cosine, because
of the plus 1 plus.
Thank you, Wissam. So that's a hint, right? The plus 1 plus means it must be cosine, and that we have to alter the angles, right, Arthur? Yes, we have to divide the angle into half, right? So it is 88 degrees. Exactly. So number 12. So I have number 12.
Sir, I have one question.
Yes.
For the quadrant, like cosine on the second quadrant, it's minus, right?
Yes.
So the plus and minus, they follow like where the angle is on which quadrant, right? For the square root.
Yes.
So for this one, the cosine. Oh, okay, so since the angle is cosine 88 is in the first quadrant, right? So that's why it's
Yes.
positive.
Yes, exactly.
Okay, thank you.
Okay, you're welcome. That we would not change this anyway. They didn't ask for minus but you're right. Usually it's between minus pi by 2 less than or equal to x less than or equal to pi by 2. But that's for the domain part inside. So the problem, I think, with some, it's not the quadrant. The problem we have is we want the square root to be defined. Oh, yes, these are the quadrants, but we want the theta to be defined. So theta would be defined if theta is between minus pi by 2 up to pi by 2, which is like half of the quadrant, right? So they didn't give us anyway. The square root of is just straight cosine of 88. So it should match. The numbers should match. The calculator will give you other. We won't give you anything else. It will give you the same. So what is number 12? What is number 12? So the square root of 2 minus 2 cosine 328. So 2 minus 2 cosine 328. If it was going to be complete, it would have been like that. And then you're going to multiply by 2 here. You know what I mean? What I'm saying is I want to make it in the shape of 1 minus cos of 2x over 2. Right? If I want to make it in the shape of, in the one in the radical, 1 minus cos of 2x over 2, I would have used, I have to factor the 2 up front, multiply by 2, 1 minus cos of 328 over 2. I would do this because I want something over 2 to make it, to change it into the half angle formula. So, and then the square root of 4 is 2. What's left is here 1 minus cos of 328 over 2, which is, somebody answered, Arten, it is 2 sine. Very good. What of sine of an angle? What? Dima, yes, 2 sine, but sine of what angle? 2 sine of, sorry. What is it? Okay, half of 328, half of 164, which is half of 328, which is 164, right? So we can double check the numbers. They will be, this number and this number are the same. So number 14. So the square root of 4 plus 4 cosine of 8 beta over 2. I don't like the square root, to tell you the truth. What I like is the squares, because in integration, the square root is not used. It is this which is used. These are the two important expressions in integral calculus that you use a lot, not the square root. No, nobody wants to see the square root. You want the square so you can easily integrate. But anyway, the book has them as a lot of square roots, but they are the same. So the square root of that could be changed into, I don't know, we can pull out the 4 and then we're there, really. If we pull the 4, 1 plus cos of 8 beta over 2. This is, of course, the inside is sine squared. I mean cos squared of half angle, which is 4 beta, right? So it's 2, the square root of 1 plus cos of 8 beta over 2, and that is 2, that is cosine of 4 beta. Number 16, and we have a missing number which doesn't completely describe, it's not completely given to us as a formula. There is a 2 missing and there are 2 multipliers in there. I will use the same way I did before. This is actually, I recognize this as sine squared, isn't it? The inside, or just simply the sign, if it's adjusted somehow because of the minus. So therefore, this is 2 into 1 minus cos of 16x. That's the first adjustment. Second adjustment, I need a 2 in the denominator. So I multiply the top by 2 and then divide by 2. The same of 1 minus 16x. So the square root of 4 is 2. The square root of that is what? Oh, sorry. Then this becomes what? This becomes 2 sine of half of the angle 8x. So I'm going to do some proofs. Number 18. Oh, number 18 is similar. I'm not going to do that. They're all the same. Like number 20 is, the question is prove that. Let's do number 20. Oh, is it simplify? Okay. Simplify the same. Simplify as, they asked us 2 cosine of squared theta over 2 times secant of theta. So it would have been nice if this was cosine squared of theta, because cosine squared of theta, secant theta is very easily simplified. 1 over secant squared of theta, secant theta. You would have canceled that. 1 over secant theta would have been just cos theta, really. But that's not the case. The angles are different. So maybe if we change this into what we call this, maybe we'll have a better expression. So what is that? Cos squared of theta. So 2 times what? Secant of theta. What is cos squared of theta over 2? Remember, cos squared is 1 plus cos double the angle divided by 2. Yes. So 1 plus cosine of double the angle, which is theta, over 2. So I'm going to simplify. 2's cancel. So what I got is 1 plus cos theta times 1 over cos theta. Secant is 1 over cos theta, if you will. So this is 1 over cos theta times 1. I mean plus 1. 1 times 1 over cos theta is 1 over cos theta. Cos theta times 1 over cos theta is 1. So this is just secant theta plus 1. I don't know if that's better, but I want to do some proofs. So from 29 to 32, prove the identities. So prove cos of theta over 2, this is number 30. Cos of theta over 2 equal to sine theta over 2 sine theta over 2. Yeah, that's what it is. Are you with me? Yes? Everybody ready to do this? We want to prove that these are equal. I think I can start from the right hand side. Start from the right hand side and show the left. And show it is equal to the left, okay? Sine theta over 2 sine theta over 2. You might choose the other way. It doesn't matter, really. I appreciate you when you do it differently from mine. I appreciate that. Okay? You don't have to follow me everything. You just have to learn from me and then develop your own skills if you can. So what is sine theta? Like I have sine theta over to the denominator. What is sine theta? Using half angle formula, we can cut it. I mean, we can cut the angle to theta over 2. We can change the angle to theta over 2. Not exactly the way it is, but if you remember the identities. What is sine theta over 2? No, what is sine theta in terms of if I want to change it into theta over 2?
Would it be 1 minus, or the root of 1 minus cosine 2 theta over 2?
Yes, but thank you so much. You're right. But what is going to help me? I want to simplify, right? I want to head towards this, towards the left. It doesn't even have a square root. So it's better something which takes me towards that. In terms of section 2, section 3, and section 4 identities that we're doing, which one is going to help you to get something like the denominator so you can cross it out? What kind of rule? What he told me is not wrong, but I don't think it will help me for simplification here. But I know what sine theta is.
It's two sine, right? Half of the angle, cosine half of the angle.
Excellent. That will help me a lot. See, remember the double angle formula? Sine of x, 2x is 2 sine x cos x. Okay? Sine of theta is 2 sine theta over 2 cos theta over 2. So if I change that into that, then there is sine theta over 2 in the denominator. I can cross out. So 2 sine theta over 2 cos theta over 2 divided by 2 sine theta over 2 was there already. I can cross that by that. So the 2's will cross out to, I will be ending up cosine of theta over 2, which is the left-hand side. So the angles are the one which guided me. Oh, I got theta over 2 in the denominator, theta on the top. So maybe if I use like double angle formula, the angle will be halved inside there. And then I might have a chance to eliminate them. So this for most part is easy, very, very easy. But most of the time, like on tests and whatnot, it's very confusing. You don't know where to start. Okay. But double angle formula on that one will help me. Double angle formula like that. If you split it further to theta over 2. Okay. So what is number 32? I haven't done it, but let's do it. Prove again cos squared of x over 2 times square brackets 1 plus sine of x over 1 plus cos of x squared equal to 1. So left hand side, of course, left hand side. The right hand side, nothing to work with. So left hand side, cos squared of x. What is really cos squared of x? Okay, cos squared of x over 2, 1 plus sine squared of x. I can multiply 1 plus cos x the whole squared, right? You don't say equal to 1. You want to say that this product equal to 1. Can you tell me what cos squared of x over 2 is? What is this? I have a problem. You cannot really assimilate the, you cannot simplify in assimilated version when you have different angles in the functions. Even to think about how to do simplify, you should think of the same angles.
Wouldn't you be able to use the double angle formula? 1 minus
Yes.
2 sine squared of x over
1
2?
1 plus cos of double the angle, which is x, isn't it?
Yeah.
Which is x, double the angle over 2, right?
Oh,
Not
yeah.
square.
Okay.
So this is exactly the application of the half angle formula. You're right. Okay, thank you. And here, I don't know if, yeah. What is a plus b over c? Isn't it a times c? We did this a lot. A times c and b over c. I'm going to do like that. 1 times that is 1 plus cos x the whole squared plus sine squared x over 1 plus cos x the whole squared, right? So far, okay? I just made these square brackets into one bracket, into one fraction, really. So this is 1 plus cos x. I have to clean up in the inside. So this is actually what? I can FOIL the first binomial. So 1 plus 2 cos x, cos squared of x, right? Plus sine squared of x. Oh, it's coming right now. 1 plus cos x the whole squared. Did you see my expansion? The first square times 2 times the first times the second plus the second square plus the second plus sine squared was there already. So 1 plus cos x, again I have to clean up in the inside there. So cos squared plus sine squared is 1. 1 plus 1 is 2. So 2, 1 plus cos, well, I'm skipping a step. So 1 plus 2 cos x plus 1. This thing is 1 using identities over 1 plus cos x the whole squared. So this is 1 plus cos x over 2. This is 2. Now I have 2. This is 2 plus 2 cos x. You can factor 2. 1 plus cos of x over 1 plus cos of x the whole squared. So 1 plus cos x cancels with 1 degree of 1 plus cos x. but 1 plus cos x will cancel with this. The 2 will cancel with this. It gives you 1. Interesting question. Now, this is a new edition. I haven't done it before, I remember. I've done them all except the new ones. I think I don't want to push it. I don't want to cover section 5 before the test. That would be enough. So test covers 24.5, 24.6, no, 24.6, only x-intercepts. And we know them from previous course. 24.7, 24.8, they are chapter 24, application of derivatives, all of them. Okay, this is optimization, this is linearization, this is graphing, right? And then from chapter 20, 20.1 up to 20.4, that's it, up to half angle formula. There are 7 sections included. The section 5, if I include it on the practice test, you should eliminate it. What is section 5 has is, say, what is sine 3x plus 5 equal to 10? Solve 4x, right? It's very important. We need section 1, 2, 3, 4 of chapter 20 to do this, really. The bottom line is, for a math student, the bottom line is you got to solve. Normally, what will you do? Sine 3x equal to 10 minus, well, this let me call this as 7. So it is, because it has no solution otherwise. Sine 3x equal to 7 minus 2 minus 5. Sine 3x equal to what? Oh, I got to say, I got to say 5.4 maybe. So otherwise it will be solution, no solution. So sine 3x equal to 5.4 minus 5. Sine 3x equal to 0.4. Now it has a solution. This number is less than 1. You got to be less than 1, otherwise error. So 3x happens to be 0.4, 3x no, 3x then is sine inverse of 0.4, you see? So this is equal to sine inverse of 0.4, second function sine of 0.4. The angle is actually in radians, I prefer, because there is a mix-up, but it is 23.6 degrees, then x is 23.6 divided by 3. So then x is 7.87 degrees, you know what I mean? So if you put 7.8 degrees here, it's going to be like that. So let's double check. Sine of 3 times 7.87 plus 5, I got 5.4 exactly. You know what I mean? So this is the process that we are in section, what do you call it, 20.5. This is the easy question I gave you. Solve this. But they got even quadratic equations, they got complicated equations. So I will delay this for test 4. I have no choice, because we will do this right after the test on Thursday. Is Silas, did you follow me? The last part you don't have to do, but it won't be on the test, but that is really the reason why I did the 5 sections, is for me, in order to solve trigonometric equations. The bottom line is, in every most of the chapters, we always do properties in mathematics, and then using the properties we try to solve. That is the objective. So this section is solved. You can read it ahead of the class, and then when you come back, we will do more of that. But actually, I have decided now that I cannot include it on the test. So the sections covered are, as I said, listed here, listed in the box here. Okay. Thank you so much. If you have questions, you let me know. But I'm done for today. I have 1 hour break, and then I have the challenge goes on today. Thank you, Sivan. If there is any questions, you let me know, please. Even if you have any question, anything. Dakari, thank you. Thank you, Michael. Spawadi. Spawadi is a nice name. I am struggling to read it. Thank you, Michael. Everybody, Dima, Wissam, Rafal, and Arthan. Try to relax a little bit so you come back with full energy. Have a good March break. Trevor, homework. Okay, Trevor. Always you're the man, like in reminding me to write the homework. Okay. So homework. Can I write here? Homework. We have to go. I don't think I assigned from section 3 either. But I will post them. You know what I mean? I'll post on Blackboard right now. Okay. Section 26 point. Section 20.3. 20.3 double angle formula. Okay. On page section 20.3 on page 561. Numbers are 5, 9, 11, 13, 15, 19, 21, 23, 25, 27, and 29. Section 20.4, page 564. My notes, I'm checking. 564 section okay, is actually number 3, number 5, 9, 11, 13, 15, 17, 19, and 33. Not 33, 35, but I want 29 and 31. 29 and 31. These are some proof. Okay. Thank you so much, Trevor. I appreciate it for reminding me. Okay. Thank you all. Michael, have a great day. Yeah. Take care, guys. Enjoy your mark break. Rest up a little bit. And don't forget to study for math.